What if a traveler from another star brushed past Mars at the exact moment we started finding the planet's strongest hints of ancient life? That's the puzzle of 3I Atlas, an interstellar comet rich in carbon dioxide that slipped near Mars while hiding in the sun's glare, as if the universe wanted the meeting private. Picture it, a rare visitor on a one-way path through our solar system, carrying the very gas that could help thicken Mars's thin air, arriving within about 30 million kilometers, close in cosmic terms, just as our orbiters looked up. Coincidence? Or a quiet nudge from the cosmos? Scientists say it's natural, not guided, yet the timing feels uncanny. A carbon dioxide-heavy comet, a once wet world, and a flyby during weeks when Earth couldn't watch. If Mars has a past written in water and time, 3I Atlas might be the mysterious footnote we weren't expecting. Maybe it's only celestial clockwork, or maybe it's a lesson arriving right on schedule. An interstellar messenger reminding us that Mars still has stories to tell, if we're willing to listen between the shadows and the sun. Leave a like and subscribe to the channel, as tonight, we will investigate this cosmic anomaly that has left astronomers speculating and conspiracy theorists asserting that it cannot be a random occurrence. In a cosmos dictated by probability and disorder, an event of such precision should not be possible. An occurrence in Mars's vicinity is challenging our fundamental comprehension of the universe's mechanics. The true purpose of Atlas's journey could prove to be the most startling revelation in all of human history. Get ready as we start our journey. For over 4 years, NASA's Perseverance rover has been methodically excavating the old mudstones of Jezero crater. However, in July 2024, a remarkable discovery was made in the Martian terrain. Scientists identified formations they have termed leopard spot textures inside a rock sample named Shiava Falls, which was gathered near the Bright Angel outcrop. These are not merely decorative geological features. They constitute one of the most compelling potential biosignatures ever discovered on Mars. To clarify, a biosignature candidate serves as a natural hallmark, a chemical or physical remnant that life may have produced. The leopard spots feature minerals such as vivianite and gragite. While these compounds can arise from non-biological geological activity, they are also frequently created by living organisms on our own planet. It is analogous to discovering footprints in primordial mud, but these impressions might have been left by microscopic organisms on Mars 3.5 billion years in the past. Jezero crater was not always the desolate, windswept depression it is today. Imagine that billions of years ago, this area contained a large lake supplied by a winding river. The delta patterns that remain in Jezero's geology recount a history of moving water, the settling of sediment, and the presence of organic chemistry, the very circumstances under which life often leaves its mark. River deltas act as nature's archives, storing organic molecules and biological evidence within their sedimentary layers with exceptional accuracy. Yet, it is here that the narrative shifts unexpectedly. As scientists were revealing this possible proof of ancient Martian existence in September 2025, another event was unfolding in the void between star systems. On July 1, 2025, the Atlas Telescope Network identified an object unlike any previously observed. It was named 3I Atlas, marking it as just the third interstellar visitor confirmed by humanity. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, functions as a celestial sentinel, surveying the sky nightly from its locations in Hawaii, Chile, and South Africa. These observatories were not constructed to locate travelers from other solar systems, but to identify asteroids that could pose a danger to Earth. Occasionally, however, the search for nearby dangers leads to far more enigmatic finds. Astronomers described 3I Atlas as having a hyperbolic trajectory, a flight path that definitively shows it came from beyond our solar system. In contrast to our native planets and comets, which are gravitationally tied to the Sun in elliptical paths, this object is merely passing through our cosmic neighborhood on a one-way journey from a distant star. With an orbital eccentricity greater than 1, it possesses the velocity needed to permanently break free from our Sun's gravitational pull. What is particularly startling is that as NASA was publicizing Mars's most promising biosignature candidate, this interstellar traveler was already approaching the red planet for a close pass. The synchronicity of these events seems almost deliberate. Our knowledge of 3I Atlas is like a chapter from a cosmic detective story. It has been verified as a natural object, showing no signs of artificial construction, radio emissions, or physics-defying movements that would point to an intelligent origin. Its chemical makeup, however, suggests a different narrative. Initial analyses by the James Webb Space Telescope and SphereX have uncovered something extraordinary. A coma primarily composed of carbon dioxide, with a CO2 to water ratio of about 8:1. Most comets are essentially frozen amalgamations of ice and dust, but this visitor appears to be venting carbon dioxide. Within the astronomy community, there is talk of a green luminescence noticed in September, a display that might signal the outgassing of dicarbon or cyanide from the comet's core. While not exceptionally rare chemicals, their high concentration in an object from another star system poses fascinating questions about its origins. The internet has, predictably, become a hotbed of speculation, with theories ranging from it being an alien construct to a terraforming device. NASA's official statements have remained scientific and cautious, noting that all data align with a natural, though compositionally strange, comet. It presents no danger to Earth and shows no proof of artificiality. Yet, the timing, the chemistry, and the unfolding narrative of this cosmic event are what command attention. If a force or entity intended to make Mars more habitable, what better delivery system than a comet laden with greenhouse gases like carbon dioxide? Such a payload could thicken Mars's thin atmosphere, capture solar energy, and initiate the slow revival of the planet. This is, of course, speculation founded on a cosmic coincidence. But the universe sometimes reveals patterns so striking and well-organized that to ignore them seems contrary to the scientific spirit. The question of what 3I Atlas is doing in Mars's orbital path will lead us through a maze of science, ancient riddles, and the chance that we are observing an event of immense importance. To appreciate the exceptional nature of 3I Atlas, one must first understand the concept of a hyperbolic orbit. Consider tossing a ball upward. It follows a parabolic path, decelerates, pauses, and returns to the ground. Now, envision throwing it with such force that it overcomes Earth's gravity and never returns. On a cosmic scale, this is what a hyperbolic orbit signifies. When astronomers calculate an orbit's eccentricity, they are assessing its deviation from a perfect circle. A circle has an eccentricity of 0, while Earth's slightly elliptical orbit is about 0.017. An eccentricity exceeding 1 indicates an escape path, guiding an object away from its gravitational anchor indefinitely. 3I Atlas has an eccentricity significantly above 1, confirming its interstellar origins. This makes it only the third such visitor ever confirmed, after the mysterious, elongated Oumuamua in 2017 and the more conventional Comet 2I/Borisov in 2019. Oumuamua displayed an odd, non-gravitational acceleration, speeding up in a way not fully explained by solar radiation, which fueled theories of it being an artificial object. Borisov, however, acted just like a typical comet, with a predictable coma of gas and dust. 3I Atlas resides somewhere between these two, making it a subject of great interest. It is clearly a natural object with no signs of technology, but its chemical profile is unlike anything seen before. The James Webb Space Telescope has been observing 3I Atlas since it was first spotted, and its findings are startling. The coma, the cloud of gas and dust around the comet's nucleus, is not dominated by water vapor as expected, but by carbon dioxide with a CO2 to H2O ratio of approximately 8:1, one of the highest ever documented. Typically, comets are like celestial snowballs that sublimate as they near the sun, forming a tail of water vapor and dust. This dirty snowball theory has been a reliable model, but 3I Atlas seems to be emitting carbon dioxide, much like a block of dry ice in a warm environment. This peculiar chemistry points to several formation scenarios. It might have formed near the carbon dioxide ice line in its home star system, or its surface may have been altered by eons of exposure to cosmic rays. Another theory is selective sublimation, where an outer layer of CO2 ice prevents deeper water ice from vaporizing. Further observations have identified other compounds like carbon monoxide and carbonyl sulfide, adding more layers to the mystery of its origin. The SPHEREX Space Telescope has independently verified these findings. In September, observers also noted a distinct green tint in its coma, often a sign of dicarbon or cyanide compounds. While not unusual for comets, abundance in an interstellar object is noteworthy. Scientists like Dr. Alan Fitzsimmons have been quick to state that while the comet's composition is strange, all observations are consistent with a natural object. However, there are significant limitations to these measurements. Spectroscopic data can be skewed by dust and atmospheric interference, and the comet's chemical ratios may change as it gets closer to the sun. We are, in effect, analyzing a distant, fast-moving chemistry experiment from millions of miles away. The fact that we can detect anything is a triumph, but what we are finding is unsettling. As 3I Atlas speeds toward Mars, these chemical peculiarities become more significant. Carbon dioxide is the main component of Mars's thin atmosphere. If one were to devise a way to make Mars more habitable, delivering a payload of CO2 would be the ideal method. For now, we are faced with unusual chemistry, coincidental timing, and a trajectory that will bring this object very close to Mars in a matter of weeks. The persistent question is, why now, why this composition, and why Mars? On October 3, 2025, 3I Atlas will pass by Mars at a distance of about 28 to 30 million kilometers. In cosmic terms, this is a close encounter, though it is about 75 times the distance from the Earth to the Moon. What makes this event so theatrically perfect is that at its closest point to Mars, 3I Atlas will be almost impossible to see from Earth due to solar conjunction. The object will be positioned on the opposite side of the Sun from us, lost in its glare. For a critical period from late September to late October, our telescopes will be unable to see what the object is doing near Mars. The timing seems almost deliberate, with maximum proximity to Mars aligning with maximum concealment from Earth. The comet will reach its closest point to the Sun, perihelion, around October 29th, placing it just inside Mars's orbit. This is the ideal position for solar radiation to maximize its outgassing. We will not, however, be entirely without a view. The European Space Agency's Mars orbiters, Mars Express, and the Trace Gas Orbiter will attempt to observe the flyby. These orbiters could provide invaluable close-up data, potentially revealing details about the comet's nucleus, detecting specific chemical compounds, or even analyzing dust particles from its tail. The scientific importance of this event is immense. 3I Atlas is only our third data point for interstellar chemistry, and its high carbon dioxide content could offer insights into how planets form in other star systems. Meanwhile, Mars itself is under intense scientific focus after the discovery of potential biosignatures. The planet's thin, CO2-rich atmosphere is a remnant of a once thicker envelope that supported liquid water. Could we be seeing more than a simple coincidence? What if the comet's chemistry is precisely what Mars needs to begin reversing its long-term climate decline? It is important to keep the scale in perspective. A single comet does not carry enough gas to significantly change a planet's atmosphere, which Mars has been losing for billions of years. But what if this is not an isolated event but part of a larger, long-term process? Reassuringly, 3I Atlas is not a threat to Earth. Its closest approach to our planet in mid-December will be at a very safe distance. Still, the overall picture is striking. An interstellar object carrying the very atmospheric components Mars lacks, arriving just as we find potential evidence of past life there, and hidden from our view during its crucial Mars encounter. If this were a film, it would be dismissed as too contrived. Ground-based observations will pick up again in late November. But by then, the comet's passage near the Sun will have changed it. The European Space Agency has been clear that an intercept mission is impossible with current technology. We are confined to observing from a distance. Perhaps that is appropriate. As 3I Atlas approaches Mars with its cargo of cosmic secrets, we are left to wonder what will occur during those weeks it is hidden from our sight and what it will reveal about distant stars and the potential future of our celestial neighbor. Let us lay out the coincidence plainly. In September 2025, NASA publicized the discovery of potential biosignatures on Mars, geological textures that could be the most solid proof yet of ancient life. Mere weeks later, 3I Atlas, an interstellar comet with a high concentration of carbon dioxide, is set to make its nearest pass to the red planet before vanishing behind the Sun. As any scientist knows, correlation is not causation. Yet, in a universe where patterns often seem to hold meaning, such an alignment of events invites scrutiny. The logical explanation is simple. Interstellar objects travel on random paths, governed by the laws of celestial mechanics. 3I Atlas began its journey millions of years ago, its trajectory shaped by gravitational forces long before humanity existed. Its hyperbolic orbit is a one-way ticket through our solar system, a path dictated by physics, not by our discoveries on Mars. However, from a storytelling perspective, coincidences build upon one another until they form a compelling narrative. The comet's perihelion occurs at the optimal time for maximum outgassing, just as it is closest to Mars and hidden from Earth's view. This solar conjunction provides a perfect veil of secrecy. Furthermore, its carbon dioxide dominant chemistry is exactly what would be needed to begin restoring Mars's thin atmosphere. There is public misunderstanding about the nature of such objects. 3I Atlas is not a steerable craft. It is a body of frozen chemicals following a path determined by gravity. NASA has consistently stated that all observations align with a natural comet, showing no signs of artificiality or intelligence. So why does the timing feel so momentous? It may be that we are witnessing the convergence of two distinct cosmic stories: the tale of Mars's ancient biology and the arrival of interstellar chemistry at the very moment we are pondering the planet's potential for life. Let's entertain a speculative thought. What if atmospheric engineering is not mere science fiction? What if the arrival of this CO2-rich comet is not a coincidence but a deliberate act of design? Not necessarily by aliens, but perhaps as a result of natural selection on a cosmic scale, where the universe tends to produce objects that promote habitability. This is speculative, but it is notable that the comet's main components, carbon dioxide and water, are fundamental to life-supporting atmospheres. Of course, terraforming Mars is a highly speculative concept, as the planet lacks a magnetic field to protect any new atmosphere from being stripped away by the solar wind. A single comet's deposit would be insignificant in the long run. But what if 3I Atlas is just one part of a larger, ongoing pattern? As the third confirmed interstellar visitor in a decade, such objects may be more frequent than we thought. This leads to two ways of interpreting the event. The scientific view sees it as an unusual but natural comet whose timing is a coincidence. The speculative view, while not necessarily invoking intelligence, questions the remarkable alignment of chemistry, timing, and destination. Both perspectives grapple with the same mystery, a moment where ancient Martian biology and contemporary interstellar chemistry are intersecting in a way that challenges our understanding of cosmic coincidence. If one were to terraform Mars, what would be delivered? The exact mixture of carbon dioxide, water, and organic compounds we see in 3I Atlas. The ultimate question is how we can tell the difference between a meaningful pattern and a random event in a universe that seems to produce both. The gaps in our knowledge about 3I Atlas, its limited visibility during the Mars flyby, and the challenges of analyzing its chemistry from afar, provide fertile ground for extraordinary theories. The comet was discovered in July 2025, giving us a very short window to study it before it disappears behind the sun. The online discussion has been predictable, with social media algorithms promoting sensational claims of alien artifacts over more measured scientific explanations. NASA's response has been a model of crisis communication. Acknowledge the unusual data, explain the potential natural causes, and emphasize the lack of evidence for anything artificial or threatening. What distinguishes this event from past false alarms is the transparency of the detection networks. The Atlas system publishes its findings almost immediately, making it impossible to conceal data. If the comet were exhibiting truly anomalous behavior, such as course corrections or radio signals, astronomers worldwide would know. This transparency debunks romantic notions of government cover-ups. The physics of space travel also limit the more outlandish theories. An intercept mission is technologically impossible on such short notice. We are confined to remote observation, much like trying to understand a person's identity by watching them from blocks away at night. These limitations, however, create space for both healthy skepticism and conspiracy theories. What would constitute proof of artificial engineering? Specific criteria include non-gravitational maneuvers, narrowband radio signals, or geometric structures. None of these have been observed. The comet's trajectory is predictable, no artificial signals have been detected, and its coma is diffuse and natural-looking. Even its strange chemistry is within the realm of theoretical possibility for comets from other star systems. But as the saying goes, the absence of evidence is not evidence of absence. The reported green glow adds another layer of uncertainty. While it could be caused by dicarbon or cyanide, the exact molecular process is unconfirmed. This is where the story's noir elements emerge. Science requires rigorous verification, while conspiracy theories weave isolated data points into compelling but unfalsifiable narratives. 3I Atlas sits in the space between these two approaches. Too strange to be entirely normal, yet too normal to be entirely alien. This ambiguity triggers what psychologists call the uncertainty effect, where our minds are more willing to entertain unusual possibilities. As we prepare to lose sight of the comet, we must confront the limits of our knowledge. When it reemerges in late November, it may have been fundamentally altered by its passage near the sun. This raises more questions. Are we observing one object or two? Is its measured chemistry representative of its entire composition? The most unsettling possibility is that we may never have definitive answers. The comet could complete its journey and return to interstellar space, leaving us with data and endless speculation. Perhaps this is the true test. Not whether 3I Atlas is natural or artificial, but whether we can maintain scientific rigor in the face of profound mystery. Can we hold two conflicting ideas at once? That the universe is stranger than we imagine, and that extraordinary claims require extraordinary evidence? The real mystery may not be what 3I Atlas is, but what its arrival reveals about our readiness to encounter the truly anomalous. Long before modern telescopes, ancient civilizations watched the skies with a mix of awe and fear. They developed sophisticated systems for tracking celestial movements but had no concept of objects from beyond our solar system. The historical record shows no verified accounts of visitors like 3I Atlas, but this may be due to observational limitations rather than their absence. A faint, fast-moving object on a hyperbolic path would have been easily missed. Yet, mythology is rich with tales that could be interpreted as distorted memories of such events. Skyboats carrying gods, celestial messengers, and wandering stars. The Sumerian epic Enuma Elish, for example, describes a being arriving from the outer darkness. While these parallels are culturally fascinating, there is no evidence linking them to actual interstellar objects. The human brain is wired to find patterns, a trait that served our ancestors well, but can lead to false correlations when applied to cosmic phenomena. Historically, comets were seen as omens. Halley's Comet in 1066 was thought to foretell the Norman conquest of England. These correlations were not causal, but the psychological impact of cosmic events often created self-fulfilling prophecies. 3I Atlas arrives at a similar transitional moment for humanity, as we stand on the cusp of becoming an interplanetary species. Is this timing significant? Or are we simply more attuned to cosmic events now that we have the tools to detect them? The anthropic principle suggests we observe the universe at the precise moment observation becomes possible. Yet, the precision of these coincidences is deeply unsettling. 3I Atlas is not just passing through. It is approaching Mars at a time and distance that maximizes scientific curiosity while minimizing our ability to observe it. Ancient cultures might have attributed such synchronicity to divine intervention. Modern culture struggles to find an explanatory framework that satisfies both scientific skepticism and our intuition that some patterns are more than mere coincidence. The planet Mars itself, named for the Roman god of war, carries cultural baggage that colors our interpretation of events in its vicinity. Perhaps the most relevant historical parallel is not in ancient texts, but in the evolution of observation itself. Each new generation of tools reveals phenomena previously unseen. Radio telescopes uncovered pulsars, space-based observatories found exoplanets, and now the Atlas network detects interstellar visitors. What if the pattern is not that strange objects arrive at meaningful times, but that our definition of meaningful expands with our observational capabilities? This raises a provocative question. If an advanced civilization wanted to leave clues for a developing species, where would they hide them? The answer might be in plain sight, encoded in natural phenomena that only become decipherable when a species reaches a certain technological maturity. These breadcrumbs would not need to be artificial. They could be natural events, timed and arranged to convey information. This is speculative, but it provides a useful thought experiment. Our approach must be twofold. We should entertain possibilities while rigorously checking them against the data. The ancient astronomers who tracked the planets were doing important work, even when their interpretations were wrong. They laid the foundation for our current ability to detect and analyze objects like 3I Atlas. We now have better tools and stricter methods, but the fundamental human response to cosmic mystery remains the same. We watch, we wonder, and we try to understand our place in the universe. Every few years, the myth of Nibiru resurfaces online, a supposed planet on a 3,600-year orbit that brings ancient astronauts and societal upheaval. This story, largely popularized by Zecharia Sitchin's translations of Sumerian tablets, has been thoroughly debunked by NASA. There is no evidence of such a planet. The Nibiru mythology exemplifies the kind of pseudoscience that makes it difficult to have a rational discussion about genuine astronomical anomalies like 3I Atlas. Legitimate scientific mysteries can get lost in the noise of such speculation. However, 3I Atlas is fundamentally different from Nibiru fantasies. It is real, its behavior follows predictable laws of physics, and its trajectory has been independently verified. This hyperbolic orbit means it is on a one-way trip, never to return. This is a matter of mathematics, not mythology. The enduring appeal of cyclical cosmic events reveals a deep-seated human need for patterns. The idea of predictable repetitions offers a sense of control over the incomprehensible. Real interstellar objects like 3I Atlas provide no such comfort. They arrive randomly and depart forever, leaving only questions. This unpredictability can be more unsettling than the certainty of myths. The contrast between science-based uncertainty and unfalsifiable mythology highlights the importance of critical thinking. Science admits its ignorance and updates its conclusions with new evidence, while pseudoscience claims certainty and resists testing. We should not, however, dismiss the psychological needs that draw people to such narratives. The universe is vast and can be intimidating. The desire to find meaning in cosmic chaos is a deeply human response. What if we could channel this pattern-seeking impulse toward legitimate scientific inquiry? With 3 confirmed interstellar visitors in less than a decade, we have a small but growing dataset. Oumuamua showed unusual acceleration, Borisov was a conventional comet, and 3I Atlas has strange chemistry and timing. This suggests that interstellar space may be more chemically diverse than our models predict. The real cycle to consider may not be cosmic but technological. Every few generations, our ability to observe the universe leaps forward, revealing new classes of objects that were always there but previously invisible. 3I Atlas is the latest product of this evolution. Our ability to detect and analyze such objects is less than a decade old, meaning we are still learning what is normal and what is anomalous. The internet both aids and hinders this progress. Discoveries are shared globally in hours, but so is misinformation. The challenge is to maintain scientific rigor while acknowledging that our understanding may be incomplete. 3I Atlas does not fit neatly into our existing categories, but that does not mean it requires an extraordinary explanation. Sometimes nature is simply more imaginative than our models. Could ancient myths be distorted memories of real astronomical events? Possibly. But there is a crucial difference between acknowledging that astronomy influences mythology and claiming that mythology accurately describes astronomy. 3I Atlas offers an opportunity to practice better intellectual hygiene. We can acknowledge its unusual properties without invoking ancient astronauts, and we can explore its implications for Mars without claiming it is a deliberate act of terraforming. The recurring human tendency to find meaning in cosmic events, and our evolving ability to test those meanings against reality, is the true cycle worth understanding. As 3I Atlas approaches its encounter with Mars, we are participating in humanity's oldest intellectual tradition. Watching the skies, seeking patterns, and trying to understand our place in a universe that regularly challenges our assumptions. Let's revisit the chemistry of 3I Atlas, a carbon dioxide to water ratio of 8:1, among the highest ever observed in a comet. To understand the significance of this, we must consider Mars not as it is, but as it once was and could be again. Billions of years ago, Mars had a thick atmosphere and liquid water. Its surface is marked by the remnants of this wetter past. So what happened? Mars lost its magnetic field, leaving its atmosphere vulnerable to being stripped away by the solar wind. Today, its atmosphere is less than 1% as dense as Earth's. It is already 95% carbon dioxide, but there is not enough of it to create significant greenhouse warming. If one could somehow thicken this atmosphere, it might be possible to reverse the planet's decline. Enter 3I Atlas, its coma dominated by the very gas Mars needs. The James Webb Space Telescope and SphereX have confirmed this, along with the presence of other compounds like carbon monoxide. It is, in essence, a chemistry kit for atmospheric engineering. Of course, the scale of such an endeavor is immense. A single comet carries nowhere near enough material to make a meaningful difference. However, what if this is not an isolated event but part of a larger, long-term process? A speculative thought experiment suggests itself. Repeated deliveries of CO2, rich materials over geological timescales, could be an effective way to gradually restore Mars's atmosphere. The comet's heating patterns add an interesting layer to this speculation. It will reach maximum outgassing when it is closest to Mars, creating optimal conditions for atmospheric delivery. Recent data has also revealed the presence of organic compounds, which could serve as building blocks for more complex atmospheric chemistry. The green glow, potentially indicating cyanide or dicarbon, is also relevant to atmospheric engineering. We must be cautious, however, about imposing design narratives on natural phenomena. The comet's outgassing is a predictable result of solar heating. The fact that it is releasing carbon dioxide could simply reflect the conditions of its formation around a distant star. One explanation for its CO2 dominance is selective sublimation, where an outer layer of CO2 ice suppresses the release of deeper water ice. The timing of this maximum outgassing also coincides with the period when the comet is hidden from Earth's view. In a science fiction story, this would be the perfect setup for a clandestine delivery. In reality, it is a predictable consequence of orbital mechanics. Yet, the coincidences are almost satirically precise. An interstellar visitor loaded with greenhouse gases arrives just as we find potential signs of ancient Martian life. Its chemistry is perfectly suited for atmospheric restoration, and its trajectory brings it closest to Mars during a period of maximum solar heating and minimum Earth observation. The European Space Agency's Mars orbiters offer our best chance of resolving these questions. They may be able to detect whether the comet is delivering significant quantities of CO2 to Mars. Evidence of intentional engineering would be subtle but potentially detectable. Focused gas jets, chemical compositions that change based on proximity to Mars, or outgassing patterns that do not correlate with solar heating. None of these have been observed, but the crucial measurements will happen while the comet is hidden from our view. The terraforming speculation, while scientifically questionable, serves an important narrative function. It forces us to see Mars as a dynamic world, not just a static museum. Whether through natural delivery or human engineering, the chemistry of atmospheric restoration remains the same. 3I Atlas may be showing us what such a project could look like, even if it is happening through purely natural means. The real terraforming may be happening in our minds, as we are forced to imagine Mars not just as it is, but as it could be. Let's be clear. There is no evidence that 3I Atlas is carrying biological material. The harsh conditions of interstellar space would likely destroy any life as we know it. However, the absence of evidence does not rule out speculation about directed panspermia, the idea that life could be deliberately spread between worlds. If an advanced civilization wanted to do this, comets would be an excellent delivery vehicle. The chemistry of 3I Atlas, carbon dioxide, water, and organic compounds, is the necessary foundation for carbon-based life. But having the ingredients for a cake does not mean you have a cake. Still, the timing is striking. Just as we find potential biosignatures on Mars, an interstellar visitor arrives with the chemical toolkit for atmospheric restoration and biological complexity. The concept of junk DNA has been largely debunked. We now know that these non-coding regions have important functions. There is no evidence of dormant cosmic software in our genes waiting to be activated by interstellar chemistry. However, the metaphor is useful for thinking about dormant potential. Mars itself might contain biological switches that could be activated by the right chemical triggers. The discovery of potential biosignatures suggests that the planet once had the necessary conditions for life. What if some remnant of that biological potential remains, waiting for the right atmospheric conditions to reawaken? This is speculative, but it is worth considering the mirror effect. The real activation happening now is human attention and investment. The discovery of possible Martian biosignatures has energized astrobiology research and focused public attention on the possibility of life beyond Earth. In this sense, 3I Atlas may be activating human behavior rather than Martian biology. The panspermia hypothesis, first proposed in 1906, suggests that life spreads through the universe on comets and asteroids. While natural panspermia is considered unlikely, directed panspermia remains a theoretical possibility. If 3I Atlas were carrying biological materials, we might expect to detect complex organic molecules or unusual isotopic ratios. So far, observations have only revealed simple carbon-based molecules consistent with natural formation. The real test will come when we can directly sample such objects. While an intercept mission for 3I Atlas is not possible, future visitors may provide that opportunity. The Mars Sample Return mission, planned for the early 2030s, will be our best chance to analyze the potential biosignatures found by Perseverance. If Mars once hosted life, and if remnants of that life remain in the planet's geology, atmospheric restoration could theoretically reactivate some biological processes. The connection between interstellar chemistry and life may be more subtle than direct seeding. Complex organic molecules from other star systems could provide the raw materials for prebiotic chemistry on worlds like Mars. The building blocks of life are distributed throughout the universe, and the arrival of carbon-rich comets at potentially habitable worlds is likely common. What makes 3I Atlas so interesting is that it is arriving at a time when we are most focused on Mars's biological potential. The comet is a kind of cosmic Rorschach test, reflecting our hopes and fears about life in the universe. The narrative appeal of this connection reveals something important about our psychology. We are pattern-seeking organisms. A reasonable near-term test would be to analyze the comet's spectral signatures for amino acids or other complex organic molecules. The Mars orbiters might be able to detect such signatures during the October encounter. Whether or not 3I Atlas carries biological materials, its arrival has already activated something profound in human consciousness. The recognition that we live in a universe where interstellar chemistry and planetary biology intersect in ways we are only beginning to understand. The question is not whether the comet will seed Mars with life, but whether its arrival will seed our minds with the curiosity and determination to answer deeper questions about the distribution of life in the cosmos. Step outside the world of astronomy for a moment and consider how stories shape human behavior. The narratives we create about cosmic events do not just reflect our understanding. They actively modify how we respond to new information and allocate resources. The history of comet interpretation is a perfect example. Halley's Comet has appeared for millennia, but each time it has generated a different response depending on the prevailing cultural narrative. 3I Atlas arrives at a time when our stories about cosmic visitors are rapidly evolving. The successful DART mission in 2022 showed that humanity can alter the trajectory of celestial objects. We have moved from being passive observers to active participants in the solar system. This new capability changes how we view objects like 3I Atlas, transforming them from scientific curiosities into potential resources or threats. Media algorithms amplify this narrative evolution. Social media platforms reward extreme interpretations and emotional engagement, allowing a single post claiming the comet is an alien artifact to reach millions, while careful scientific analysis remains buried in academic journals. This creates a dangerous feedback loop where sensationalism crowds out nuanced discussion. The planetary defense infrastructure that detected 3I Atlas is a remarkable achievement of international cooperation. This global surveillance network has dramatically reduced the risk of a surprise impact, but it has also created a new kind of public awareness. We now live in a world where interstellar objects are detected and announced within days, complete with orbital calculations and risk assessments. This rapid flow of information enables unprecedented scientific collaboration, but it also creates opportunities for misinterpretation and speculation. The challenge is to maintain scientific rigor while acknowledging that our understanding is incomplete. 3I Atlas does not fit neatly into our existing categories. Its chemistry is unusual, its timing is coincidental, and its behavior during the Mars encounter will be difficult to observe. These uncertainties create space for both legitimate scientific speculation and unfalsifiable conspiracy theories. The key is to develop better tools for distinguishing between productive uncertainty, which drives scientific inquiry, and destructive uncertainty, which undermines evidence-based decision-making. Educational institutions play a crucial role here. How we teach students to evaluate evidence and tolerate ambiguity will determine whether future generations approach such mysteries with curiosity or credulity. The economic implications are also significant. Public support for space exploration depends on compelling narratives about why these activities matter. 3I Atlas offers a chance to demonstrate the practical value of astronomical surveillance while highlighting the intellectual excitement of space exploration. But there is a responsibility that comes with this kind of storytelling. If we overemphasize the dramatic aspects, we risk creating expectations that reality may not meet. If the mystery deflates into a mundane explanation, will public interest and support suffer? A healthy toolkit for evaluating cosmic anomalies should include source verification, statistical literacy, predictive testing, and a tolerance for uncertainty. As we approach the October encounter, these narrative dynamics become increasingly important. How we tell the story of what we observe will influence public support for continued space exploration and planetary defense. The hidden influence of these stories extends beyond policy. It shapes how we see our place in the universe and our preparedness for future encounters with the unknown. If 3I Atlas is a test, it may be a test of our collective ability to maintain scientific curiosity while resisting the urge to impose premature explanations on incomplete data. Here is a speculative twist that could explain the uncanny timing and chemistry of 3I Atlas without involving extraterrestrial intelligence. What if the aliens responsible are actually us? Or, more precisely, an earlier version of human civilization that achieved technological maturity, then collapsed, leaving behind automated systems that continue to operate. This hypothesis requires us to imagine a human or human-like civilization achieving interstellar capability millions of years ago, then suffering a catastrophic collapse that erased most traces of its existence. Before their decline, they might have deployed self-replicating atmospheric engineering systems to maintain habitability on potentially life-supporting worlds. What evidence would we expect to find of such a predecessor civilization? Industrial pollution in ice cores, unusual isotopic signatures, or artificial structures on the moon are some possibilities. Remarkably, none have been found, but our ability to detect such subtle traces is still improving. If such a civilization did exist, Mars would have been an obvious target for atmospheric restoration. An advanced human civilization might have deployed automated systems using interstellar comets as delivery vehicles, programming them with the optimal chemical compositions. In this framework, 3I Atlas would not be a natural comet but an engineered delivery system, timed to arrive when a successor civilization, us, develops the capability to detect and potentially assist with the project. The comet's chemistry supports this speculation. The 8:1 CO2 to water ratio is optimized for Mars's atmospheric conditions, and the timing of its outgassing suggests deliberate targeting. However, this hypothesis faces significant challenges. Programming comets for such precise interstellar travel would require technology far beyond our own. We would also expect engineered objects to exhibit clear signatures of artificiality, which 3I Atlas does not. The hypothesis is worth considering, though, because it addresses the central mystery of timing and chemistry without invoking external intelligence. It also explains why the comet appears natural to our instruments. Advanced engineering might be designed to be subtle. In this scenario, 3I Atlas would function as a kind of cosmic test, gauging our scientific maturity. The falsifiability of this idea is both its strength and its weakness. We could test it by looking for additional engineered signatures, such as targeted chemical releases or communication protocols, during the Mars encounter. Even if we found evidence of engineering, the assumption that human predecessors were responsible remains speculative. The galaxy has had billions of years to produce other technologically advanced species. The psychological appeal of the earlier humans hypothesis is that it addresses our cosmic loneliness without introducing truly alien intelligences. We are more comfortable with the idea of discovering our own forgotten capabilities than encountering genuinely alien technology. The timeline for such a scenario would be immense, and Earth's geological record shows no clear evidence of a prior industrial civilization. However, a space-based civilization might leave fewer planetary traces. Alternatively, the predecessor civilization might have originated on Mars itself. If an intelligent Martian species developed interstellar capability before their planet's atmospheric collapse, they might have deployed long-term restoration systems. This would explain why the comet's chemistry is so well suited to Mars's needs. The engineering challenges remain formidable, but the alternative, that the comet's chemistry and timing are pure coincidence, is also difficult to accept. Perhaps the real test is whether we are prepared to recognize engineering that operates on scales far beyond our current technological framework. As 3I Atlas approaches its encounter with Mars, we are forced to confront the possibility that we are part of a much larger and older story. The comet may be delivering more than just chemicals. It may be delivering a message about human potential, cosmic responsibility, and the long-term consequences of technological development. Imagine for a moment vast computational networks buried beneath the world's great deserts, quantum processing systems designed to model civilizational collapse, and coordinate planetary restoration projects across galactic distances. This is science fiction, but it provides a useful framework for thinking about how an advanced civilization might approach long-term survival. The speculative concept of quantum archaeology suggests that a sufficiently powerful computer could reconstruct historical events from the faint physical traces they leave behind. If such technology were real, a civilization facing collapse might deploy systems to predict the optimal time for species recovery assistance. These buried networks could monitor planetary conditions and activate delivery systems when an emerging civilization reaches the right level of maturity. In this framework, the arrival of 3I Atlas would not be a random coincidence but the output of a predictive algorithm that identified this moment as optimal for supporting Mars's atmospheric engineering. The comet's arrival coincides with our discovery of Martian biosignatures and our growing awareness of climate engineering. This is, of course, highly speculative. We have no evidence of buried supercomputers or quantum archaeological capabilities. However, the metaphor is useful. Modern computational networks, like the Atlas telescope system, are not entirely dissimilar. They process vast amounts of data to identify anomalous patterns. The DART mission proved that we now have the capacity to deliberately alter celestial mechanics. We have become active participants in our solar system, though our capabilities are still nascent. Desert environments would be ideal for preserving such hypothetical systems for millions of years. While no such networks have been discovered, our survey technologies are constantly improving. The psychological appeal of this idea reflects our own growing awareness of civilizational fragility. The thought that someone else has already solved these problems and deployed assistance is comforting, but comfort is not the same as accuracy. The speculative framework of quantum archaeology and desert supercomputers provides interesting metaphors, but it should not be mistaken for evidence-based analysis. The real archaeological project we are engaged in is more modest, using powerful instruments to study interstellar visitors and gradually build a database of observations that may eventually reveal patterns. 3I Atlas may indeed be part of a larger pattern, but that pattern is more likely to involve the natural chemistry of interstellar space than buried supercomputers. The universe is under no obligation to provide us with easy answers. What if the real test is not whether we can recognize advanced technology, but whether we can maintain scientific curiosity and rigorous analysis in the face of phenomena that challenge our assumptions? Perhaps the most important question raised by 3I Atlas is not what it is, but how we choose to respond to it. The comet's unusual chemistry and uncanny timing create a perfect test of our intellectual maturity. Do we leap to comforting explanations, or do we embrace the harder path of scientific investigation? This test is not necessarily literal. The universe regularly presents us with phenomena that challenge our assumptions and force us to choose between rigorous inquiry and wishful thinking. How we respond determines our trajectory as a scientific civilization. Consider the real-world questions posed by this event. Can we maintain funding for Mars sample return despite political pressures? Can we keep astronomical survey networks operational and transparent? Can we resist the temptation to sensationalize genuine mysteries for social media engagement? These are concrete policy decisions that will determine our ability to recognize and respond to genuinely anomalous phenomena. The successful DART mission provides an encouraging model. Rather than panicking about asteroid impacts, we methodically develop detection and deflection technologies. This evidence-based approach contrasts sharply with the viral speculation that has surrounded 3I Atlas. NASA's response to the artifact claims illustrates how scientific institutions should handle public speculation. They provided clear, factual information, acknowledged uncertainty, and maintained rigorous standards for extraordinary claims. The upcoming Mars flyby and perihelion passage provide concrete opportunities to test our analytical frameworks. If the comet is artificially guided, we would expect to see it violate conventional orbital mechanics. In the absence of such evidence, the scientific default is to assume it represents unusual but natural phenomena. The global network of astronomical observatories that tracks such objects is one of humanity's great achievements. Its transparency makes it virtually impossible to suppress evidence of genuinely extraordinary phenomena. The European Space Agency has been exemplary in providing regular updates, enabling public participation in the scientific process. The choice between transcendence and packaged solutions is a choice between intellectual work and instant gratification. Transcendence requires us to do the hard work of understanding complex science and tolerating uncertainty. Packaged solutions, like alien artifact theories, offer immediate answers without demanding any real learning. The moral dimension of this choice is significant. As we expand into space, we will inevitably encounter more phenomena that challenge our understanding. Our response to 3I Atlas is a preview of how we will handle truly extraordinary discoveries in the future. If we can maintain scientific curiosity while resisting premature conclusions, we demonstrate our readiness for the bigger mysteries that await. The test is not whether we can solve the mystery of 3I Atlas, but whether we can maintain intellectual honesty in the face of phenomena that resist easy categorization. October 3rd, 2025, is more than just a date on the astronomical calendar. On this day, 3I Atlas will make its closest approach to Mars. Two narratives will intersect: the ancient story of a world that may have once hosted life, and the contemporary story of interstellar chemistry arriving from a distant star. The European Space Agency's Mars orbiters are our best hope for obtaining detailed observations during this encounter. The most likely scenario is standard cometary outgassing, but any deviation from expected behavior could indicate something more. Here, the two competing narratives diverge. The gift drop terraforming fantasy suggests the comet will exhibit targeted behavior, releasing concentrated bursts of CO2 toward the planet. The natural comet reality predicts it will behave exactly as cometary physics suggests, following a precise hyperbolic trajectory with no signs of intelligent guidance. The comet's 8:1 CO2 to water ratio is a perfect metaphor for how we process ambiguous information. Like CO2 thickening an atmosphere, easy explanations can thicken our beliefs until we lose sight of the evidence. The question is whether we will maintain the intellectual equivalent of Mars's thin atmosphere, transparent enough for clear observation, or allow speculation to obscure our understanding. The comet's trajectory poses no threat to Earth, but the timing of its solar conjunction creates perfect dramatic tension. For several weeks, our most powerful telescopes will be blind to what happens during this crucial period. However, astronomical invisibility is not the same as cosmic secrecy. The laws of physics will continue to operate, and any unusual behavior should leave detectable traces. The European Space Agency has been commendably transparent about the observational challenges and opportunities. Unlike previous interstellar visitors, 3I Atlas provides a unique chance to study interstellar chemistry in the vicinity of a potentially habitable world. Post-perihelion observations will reveal how solar heating has altered the comet. The Mars Sample Return mission could provide definitive answers about ancient Martian life, which would contextualize the comet's arrival in entirely new ways. If Mars once hosted life, the delivery of atmospheric chemistry becomes part of a larger narrative about planetary habitability and biological recovery. But we must resist the temptation to connect these phenomena prematurely. The universe is under no obligation to provide us with narratively satisfying explanations. The choice at Mars is a fundamental decision about how we approach cosmic mysteries. with rigorous scientific methodology or with pattern-seeking speculation. If we choose the scientific path, we will continue to monitor the comet, publish our findings transparently, and update our conclusions based on evidence. If we choose the speculative path, we will impose narratives on incomplete data. The pivot point is not about 3I Atlas. It is about us. Are we ready to encounter genuinely anomalous phenomena without losing our intellectual balance? In a few weeks, as an interstellar visitor sweeps past Mars while Earth looks the other way, we will discover what kind of cosmic citizens we have become. We are not just observing a comet. We are choosing the intellectual framework that will guide our response to all the cosmic anomalies yet to come. In the shadow of Mars, an object from the deep past of another sun is exhaling carbon snow, carrying chemistry we are only beginning to understand. The hypnotic rhythm of cosmic coincidence has brought us to this moment. An interstellar visitor, loaded with atmospheric restoration chemicals, arriving just as we find the strongest evidence yet for ancient life on the red planet. What we know for certain is this: 3I Atlas is from beyond our solar system. Its coma has an unusually high concentration of carbon dioxide, and it will pass by Mars at a safe distance before disappearing from our view during the most critical phase of its journey. What remains unverified, despite compelling speculation, is that it represents anything more than natural processes. The theories of alien artifacts, DNA activation, and 3,600-year cycles are unsupported by data. Yet, the accumulation of coincidences challenges even the most rigorous scientific skepticism. The timing of its arrival, the chemistry so perfectly suited for Mars, and the orbital geometry that maximizes scientific intrigue while minimizing observational certainty. These patterns might be meaningful, or they might simply reflect our own pattern-seeking minds. Here, at the crossroads of speculation and evidence, we face a choice that transcends this single event. Do we choose transcendence through patient investigation and evidence-based understanding? Or do we choose the safety of premature conclusions that comfort our need for certainty? Transcendence requires intellectual courage. It demands that we fund the telescopes, train the scientists, and maintain the international cooperation necessary for genuine scientific progress. It asks us to tolerate uncertainty and do the hard work of learning, rather than accepting packaged explanations. Safety, by contrast, offers immediate relief from cosmic anxiety. Theories of alien artifacts and ancient astronauts provide instant explanations that demand nothing from us except belief. But the universe seems designed to reward curiosity with discovery, investigation with insight, and patience with understanding. The detection and analysis of 3I Atlas represent humanity's growing capability to comprehend interstellar phenomena. As our detection networks improve, we will develop better frameworks for understanding such objects. The Mars Sample Return mission could provide definitive answers about ancient Martian biology, which would further contextualize this event. But even if ancient life is confirmed, we must resist the temptation to impose teleological explanations on natural processes. The universe might be more conducive to life than we currently understand, without being deliberately designed for it. The choice between transcendence and safety has concrete consequences. If we choose rigorous investigation, we build the infrastructure necessary to recognize genuinely extraordinary phenomena in the future. If we choose premature certainty, we risk creating cognitive frameworks that blind us to discoveries that do not fit our preconceptions. As 3I Atlas completes its invisible Mars encounter, we will have months of additional observations to refine our understanding. The data will either confirm our natural comet hypothesis or reveal anomalies that challenge our current frameworks. Either outcome is a success for the transcendent approach, as it will expand human knowledge. The safe approach, by contrast, would only succeed if reality conforms to our immediate preferences, an outcome the universe is unlikely to guarantee. What is 3I Atlas doing in Mars's orbit? Exactly what nature does, following the laws of physics. Unless we choose to see something more in patterns that may reflect our own hopes and fears more than cosmic reality. The final call is to ourselves. Will we choose the transcendent path of evidence-based curiosity or the safe harbor of explanations that ask nothing of us but belief? In the shadow of Mars, an interstellar visitor continues its ancient journey. The universe waits patiently for us to develop the tools necessary for genuine comprehension. The choice is ours, and the consequences will echo into every future encounter with the unknown. Choose wisely. The stars are watching.